Right, so welcome to lesson 4 of your unit on electricity, and this lesson is on resistance. Now, resistance is a term that we've touched on previously in terms of it's the opposition that a component in a circuit provides to a current, slowing it down and not allowing electrons to move through it as quickly. So that's what we're going to be exploring today. So to begin with, can you have a look at the knowledge check questions? Pause the video, recap your work from the previous lessons and see if you can answer any of them. And then when you've done, unpause the video and we'll show the answers. Right, you'll have unpaused the video, so as you'll see, the answers are below. So identify the equation for current flow. So I equals Q divided by T. Current equals charge divided by time. That's what that means. Charge is measured in coulombs. Current is measured in amps. Current in a series circuit, so current is the same across each component. The potential difference in a parallel circuit. So the potential difference across each component is the same in a parallel circuit. Describe the potential difference in a series circuit. Remember opposites. So the potential difference is shared across the components. And then same for current in a parallel circuit. Remember opposites. The current is shared across the different branches as opposed to being the same as it is in a parallel circuit. And identify the symbol for charge. That symbol is a Q. So turn on to the next page. Now, to begin with, let's just get that in straight. I'm going to look at this idea of resistance. So, let's read through the paragraph together. So it says resistance. To make a current flow across a conductor, there must be a potential difference across the conductor. So remember, current is electrons moving through a material, and the current flowing through a conductor. The conductor is the material that allows electrons to flow through it. And when we're talking about flow, we're talking about the rate at which these electrons move. So there must be a potential difference across the conductor. Now remember, we described potential difference as a force that gives electrons potential energy to move, gives them a push, as it were, to get through the conductor and around the circuit. So the potential difference is the energy which provides the push for the electrons to flow through the conductor. In an electric circuit, the conductor is normally copper. However, nichrome is another type of wire which can also be used. It's harder to push the electrons through nichrome, a bit like walking up a steeper hill. Less current flows through for the same potential difference. We say the nichrome has more resistance than the copper. So nichrome is a metal that's got a high resistance. Copper has got a low resistance because, as it says here, less current flows for the same potential difference. That means through nichrome compared to copper, you have got less electrons moving for the same amount of voltage push force that's given to them to try and get them through that material. So therefore the nichrome, the resistance is higher. So you can add those annotations to your notes, and when you've done that, pause the video, go look in the description below, and you will find a first video on resistance that I want you to pause